everybody, this is going to be my technical presentation on free turn, also known as HDT, high dynamic turning. Basically, it's a new type of turning that I believe was invented by Sarah Titsett that allows you to use your head spindle as kind of another axis, so you can rotate your turning tools and that kind of thing. So we're going to be machining this chess piece here today, but before I get into kind of the technical side of things, I wanted to show a video of how this works in real life and a comparison to traditional turning. That way you can kind of see what we're going to be setting up and how it's all oriented. So I'm going to switch to this video here, and I'll kind of narrate as this goes along. At the top, we're going to be seeing the traditional conventional turning with the traditional tools. On the bottom, we have our high dynamic turning or free turn, and you can see that it's kind of like a triangular rod, and you can actually use all three of those sides of the triangle to cut. So if you need a new tool, it just rotates your spindle, indexes to that, and now you have a new tool. So that's saving you a lot of this tool change time. In addition, you can have maybe those two short ends as your roughing tools. You can see how deep of cuts it's taking, and then once you're all finished, have it indexed to the sharper point, and that allows you to do a better finish. And you can see here also that it's going back and forth, which is really a huge advantage. And you can see through this video how much faster that we're able to machine this, almost exclusively because of that functionality. With high dynamic turning, you can also run at feed rates about 40% faster, and you can also take a lot deeper cuts. And that's kind of because we're not using these really thin tools that to get in, like, as you can see in the top, like some of these nooks and crannies. Because it indexes and because it rotates, it can get into those nooks and crannies without having a really thin insert, which allows us to take deeper cuts. And you can see that midsection there, that was all done in one contour cut, and that's what we're going to be doing in our demonstration today as well. Kind of impressive cuts here. Again, you can see our finishing here on the bottom. And as I alluded to before, this video kind of cut the conventional tool changes out, but they are doing tool changes, whereas the high dynamic turning is not. So it's even machining this part faster than we're seeing. And there we have it. The high dynamic turning is done. I believe that the conventional turning here at the top has about 2 minutes left almost. So it finished this part in half the time. This is an aluminum, and with the advantage of free turn, your advantages increase depending on the softer of the material. So this is aluminum that we're machining here. However, it does have a place in all types of turning. One thing I forgot to point out here earlier is that at the conventional here, we're looking at it from the side of the machine, right? But in the high dynamic turning view here at the bottom, we're actually looking upwards towards the spindle. So you can't tell because it's a cylindrical piece that we're turning here, but the view orientations are a little bit different. Okay? So I think you guys understand. I'm going to go ahead and stop this video, and let's go back to GibbsCam here. So how do we do this in GibbsCam? First, the first and most important thing I would say is that the tooling here. So everything we're going to be using today is actually a form tool. We went out to Sarah Tissett's website, and we downloaded all their dimensions for all their different tool tips and all that kind of thing. And then in addition, I went and I got their They're tool holders. You just download like a solid model of them, and you can import that into GibbsCam and set it all up through the intermediate tooling here, right? And we're going to be talking about that in a different portion of the class, not in this particular video. And that's just because it's kind of its own separate topic. So if you'd like to know more about that, feel free to tune into that video, but I'm not going to be showing too much of that in this, okay? So that's what the tools look like in GibbsCam. Again, they are form tools here. So let's start creating our own, okay? So I'm going to go to a home view here, which is just the same as the top view, and I've set up some work groups here with a bunch of different stuff on them. But what I really want here is, again, that those DXF dimensions that I got from Ceratiz's website. So this is what the tool looks like. And if you're familiar with 2D form tools, you know that the tip that's touching the origin is going to be the one that we're using. So this is going to be kind of that finishing tool that we talked about in our orientation here, right? So all I have to do is double click this to select, and let's create a new tool. We want it to be a 2D form tool. I'm going to hit apply here, and you see we have our tool pop up here. I have a thickness of 3. Now, one thing I didn't point out is Ceratiz does all their tooling, as far as I could find, their free turn tooling in metric. Okay, so that's why I have millimeters here. So this is a 3 millimeter thick tool as of right now. It doesn't matter too much because we're going to be adding that holder on, like I said before, but just keep in mind that it is millimeters and this is an inch part, and so GibbsCam does all that kind of translation stuff behind the scenes, and you don't really have to worry about it, okay? So let's add our tooling now. I'm going to use the 55 degree, 80 degree, so these fat sides here are 55 degree tools, whereas this is an 80 degree, kind of more for finishing, in my opinion, but you can use it however you like. So all I have to do is select that one, and it kind of populates it in. And you can see here from this little tree in the bottom left-hand corner that there are 3 attachment points. And what that is denoting is we are actually going to be having 3 tools on this one tool holder, right, on this insert holder. So all I have to do is click that, and then I can go close it. And over here in our preview down here, you should see that it looks pretty good to me. Yeah, looks good to me. One thing that's kind of nice to do, and that I recommend doing, is checking this little box down here that says tool ID number and kind of putting in a tool, because even though they're separate tools in GibbsCam, we're going to be having a tool 5, 6, and 7. It's all technically kind of the same tool, right? So how does that happen? Well, we're going to have a tool 5 here, but then we want this tool ID to be 5 for all 3 of these, so that the programmer or whoever else is setting up the machine knows, hey, there's actually not 5, 6, and 7 tools, there's just a 5. All right, so we got to continue the same strategy for the other corners of the tool. Now, all I did here is I took this and I created a new work group, and then I rotated it and translated it so that the corner that I want is touching the origin. That's just kind of basic form tool stuff. So I'm going to double click that, and we're going to do the exact same thing, 2D form tool. We're going to hit apply, and you see that the point that it's calculating with is on this corner now. We're going to add that same insert, and you can see that this kind of looks funky, right? It's not quite aligned to how we're going to use it. So you have to select the correct attachment point. In this case, it's going to be attachment point 3. If you're unsure, just look at the graphics area and choose the attachment point that kind of aligns, right? So this is attachment point 2. And again, I want to change that tool ID number back to 5 so that people know that it is the same tool. Okay, and we got one more attachment point here. All right. Once you know what you're doing, it really doesn't take long to set up at all. Okay. Cool. So that's all there is to it. I have my tools all set up here, right? And we're ready to actually start machining this bad boy. I'm going to turn off my geometry for just a minute. I typically like to use a profiler, although you will see throughout this exercise that there are indeed cases where the profiler will not cut it, so to speak. Okay, so let's turn on our profiler here. This just grabs our outside shape, and I'm going to start by using this tool 6 here. I believe is one of the side ones here. Yeah, so this is going to be my roughing corner. I'm going to bring this down. If you're familiar with turning, as far as roughing operations, it's exactly the same. There's really no difference at all. GibbsCAM is intelligent, and it looks at your tooling and your holders and all that, and it knows that we're going to be doing free turn, right? Okay, so I want to do a front face here, and I'm only going to really come off the edge like 0.1 to kind of clean up some of this facing allowance that we left on here earlier. And I'll also go ahead and leave like 5,000 stock, and that's because this is a roughing operation, right? I want to be cutting on the positive X side, and the reason for that is it looks nicer, and we'll be able to see it when we actually simulate it. Yeah, you don't have to do that. That's just how I want to set this up. So again, really nothing else I need to dwell on here. Another important thing, though, is the rotate tab here. So because we have a tool that can rotate dynamically, we want to kind of angle it. And this can be an iterative process. I just know from past experience that I really want to look at like a 45-degree angle, and that's because we're cutting with this side of the tool, so I want to rotate it and have it lock in that position at 45 degrees, okay? But that's the only new thing. The rest is history. I'm going to do a little more than a facing operation here, but I'm still just taking out the front face here. Okay, I'm going to hit do it, and you notice when I hit do it that the toolpath appeared and then it flipped down to the YZ plane, right? And that's because, again, it knows that our spindle's coming down here. My approach is a little messed up, but I'm not going to dwell on that. That's not what we're here to learn. You guys know how to fix that. It knew to automatically flip it to this plane because of our tool orientation. Okay, so if I jump into my machine sim here, I have a DMG Mori CTX Beta 800 loaded up. And let's kind of slow this down and show you how it works here. So again, we locked the spindle in this operation. We're not rotating at all. This is not necessarily where the magic happens. So I won't dwell on that too much. We're ready for our next operation. I'm going to turn off my profiler. We won't be needing it. I extracted some geometry and manipulated it a little bit to kind of get what I wanted for these subsequent operations. Okay, so now let's do the same thing. I want to use the same tool, and again, I'm going to be doing a roughing operation. Now this time it's actually on the OD, right? I'm not doing the front anymore. And I want to make sure that I'm cutting the positive X side just so that we can see it when I simulate it. You can do whatever you want when you're actually machining this. Again, I'm going to leave 5,000 finished stock just so we have something to take off in a later operation. But that's it. That's really all there is to it. Now, I played with this one, and I know that an 85 degree is a good angle, and you can see that dynamically update when I populate this this box here, right? And so in this one, the reason that I extracted geometry and made my own geometry is I don't want to cut this part just yet. So I just kind of want to rough all this out in a somewhat traditional manner, and I don't want to bother trying to get in here. So that's that. I'm also not going to try and cut back here because that's where we're grabbing, right? So I want to end right here. I think is probably pretty good. Make sure that we're starting past our 0. Although we did finish or face that already, so it's not too big of a deal. We want to make sure that we select the correct circle so that we know what side of the line we're cutting on. You have to do that whenever there's geometry. The profiler last time was intelligent and it can tell which side the solid is, but geometry is a little different. So that's all there is to that. Again, we see the toolpath kind of generate up here and flip right down. Let's go back into our machine sim. I'm going to play this relatively slow. We'll watch the first operation again. You can see it rotated a little bit there. And now, one thing I forgot to point out is you see how it's going back and forth. So it's simultaneously forward turning and back turning, making this operation, this roughing operation, go like up to 2 times faster than if we were just going forward and we had to come back to the front and go forward again. So we're really speeding up this operation. I know it's hard to tell from the simulation, but that's that. Okay. All right. So that's the roughing out of the way. The roughing is pretty easy. There's a little bit more to the contour, and the reason for that is because so far in these operations that we've done, we just locked the spindle in a specific orientation and then just roughed the whole thing out. But now, when we're contouring, I really want to hug the whole part as we go deep, right? As we get into this this kind of corner down here, this area down here. So it's going to be dynamically rotating, and now because of that we have to do a little bit more geometry setup here, okay? So this is something I set up beforehand. Again, this was just all extracted, and then I deleted a bunch of stuff I didn't need. I made lines here, so I just did if you're unfamiliar real quick, I just did a point angle, and I selected one of these points, and when you do that it fills this box in, and then you just tell it, hey, I want the line to be at this angle or whatnot, right? So this is a 135-degree angle here. And that's how we got these kind of lines, and these lines are what we're going to use to angle our thing, okay? So I'm going to be using tool 7 here, just because it can get deep. We don't want to use the tip just yet, because we're going to be doing this in a contour, so I'm not going to be taking multiple passes. I'm just going to do it all in one fell swoop. Okay, so contour, OD, I'm going to adjust my clearance plane here. 0 stock. We're going to do another operation, but this is going to be somewhat of a finishing operation, so I'm not going to bother with all that. Just double checking everything here. I think it looks good. Now, here's the new thing. So this is what we're used to seeing when we were doing the roughing operation, right? However, if you check this variable B, and people who are familiar with using B-axis turning in GibbsCam, it's exactly identical. It's the same thing. GibbsCam just kind of posts it a little bit different based upon, you know, how your tools are set up and that kind of thing. So I want to select vectors, and these are going to be our tool angle vectors, and you also want to have this here say insert vectors. That's just how you do this, and we're going to be selecting multiple features because I have multiple lines here that I want it to be rotating our tool the whole time that it's doing this. Okay, so first thing you want to do, and this is a little bit different from some GibbsCam stuff, where I want to select the geometry first before I select my vectors. And the reason for that is if I select my vectors first, it kind of interprets my selecting the vectors as my selecting the geometry that we're cutting. So it'll actually try and use these lines to cut my part, which is definitely not what I want to do. Okay, so now that that's selected, I'm going to hit select vectors, and I want to select them in the order that we're going to be doing this. And I'm actually doing this backwards. I'm going from left to right here. So holding the control key down, I want to click on the part of the line that's facing towards the head. Okay, so the outside of our part. Here, 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 and here in order, right? And then just say OK. All right, and one last thing that you have to do, I'm not sure, I'll mess it up just on purpose here. It gives you a little warning here saying, hey, you have to select the center when using Form Tool with B-axis turning. Okay, that's nothing new if you're familiar with B-axis turning. So all that's saying is it wants me to select this little circle here in the middle. But I do that, and that's that. And so you can see that it made our operation and flipped it down to this plane. Okay, now I'm going to go into my machine sim and I'm going to set up a stop before operation 3. Just so we know those first two operations are good, let's not dwell on it. Okay, so this is where we left off last time, and now I'm going to slow it down. And you can see it kind of rotate right into that corner. One big deep cut. Super quick, very nice. That's exactly what I wanted. All right, so we have one more operation here, and that's just going to be a finishing operation. Let me turn off my second spindle. We actually don't use it for this part. Okay. And so same kind of thing that we just did. There's a couple more lines, but the concept is identical, right? And if I wanted to, I could actually maybe steal this old operation, but let's make a new one. Let's make a new one. I suppose it doesn't hurt to reiterate things, right? So, back to my work group here. For this last one, I want to be using my tip, so that the very front part of our tool, because it can get in kind of narrower places down here and all that good stuff. So that's what I'm going to be doing for this last operation. Again, it's a contour. OD. We want to be cutting the positive side, not leaving any stock, but everything else is exactly the same, right? Okay, so going to our rotate tab, we have our variable B. Remember that we select our geometry first. I will be starting off here. I'm going to go forward this time. We need to select the center circle. And I don't want to go this far back, right? I'm going to actually go to this line, but I'll stop before we hit our, I'll stop before we hit our chuck, right? That'd probably be a good thing. Okay. That's probably fine. We got our center circle. All right, I think we're ready to do our vectors now. Got to be a little bit careful here, just because when I'm zooming in and out, you don't want to accidentally select our geometry, because then we have to do this again. So I'm going to be very careful when doing this. Sometimes I do screw this up, so just bear with me, but I want to select the outside line. There we go. And then this guy, this one, this one, this one, this one, and that's it. That should do it. Okay, so press that, and let's just check our toolpath. It looks pretty good, but we don't know until we simulate it, right? Okay, so again, we have our op stop. Boop. And then I'll just go a little slow from here on in. It's going to rotate to that first position. And you can see it kind of rotate as it goes all the way through our part. And that's it. So I did the entire part pretty quickly with 4 operations, and kind of one tool. I did have these tools up here defined, but I didn't actually use them. So that's really the power of FreeTurn, and I think it's pretty easy to pick up, especially for people who have been doing B-axis turning and even regular turning in the past. So that's the end of this program, of this video, but I hope you enjoyed and I hope you learned.